Hello everyone, and welcome back to the Fluctus Channel. Sweden's military has long balanced neutrality with readiness. Historically avoiding major conflicts, Sweden still maintained a strong defense posture throughout the Cold War, preparing against potential Soviet threats. Its armed forces are highly modern, focusing on rapid mobilization, advanced air power, and coastal defense. Taking a closer look at Sweden's most formidable artillery piece, the Archer system. Designed with speed, accuracy, and protection in mind, Archer is a 155mm self-propelled howitzer mounted on a robust chassis. Its mission is simple: deliver devastating firepower and then relocate before the enemy can respond. What makes Archer truly stand out is its automation. With advanced fire control systems and an automatic loader, the gun can unleash multiple rounds in under a minute, reaching targets more than 30 kilometers away, with standard shells, and up to 50 kilometers with advanced ammunition. From the safety of an armored cabin, the crew manages targeting and ammunition, while the system itself handles the heavy lifting. Once a fire mission is received, rounds are selected, loaded, and fired in rapid succession. Within moments, Archer can fire, reposition, and prepare for its next strike, minimizing vulnerability to counter battery fire. This blend of mobility, precision, and automation makes the Archer not just a howitzer, but a cutting-edge artillery platform designed for modern warfare. Sweden's investment in Archer underscores its commitment to defense and its reputation for engineering excellence. To defend against enemy artillery systems like Sweden's Archer system, the U.S. Armed Forces use a special point defense system named Counter-Rocket Artillery and Mortar, CRAM. Which is considered the last line of defense against a hostile projectile strikes. The CRAM consists of a variety of systems that provide command and control capability, as well as the ability to sense, warn, respond, and intercept incoming rounds. In its land-based configuration, a land-based phalanx weapon systems, LPWS, is mounted on a wheeled platform such as a Hemti in order to provide both a stable sight and mobility to allow for repositioning. Assembling a CRAM involves a series of steps, such as placing a large ammunition drum to provide ammunition for its marvelous 20mm M61 Vulcan Gatling gun. After loading the ammunition drum with high-explosive incendiary rounds, the crew unpacks and inspects the radar system, command and control equipment, power supply units, and sensors to ensure everything works fine. The CRAM can fire at a rate of 4,500 rounds per minute. Therefore, the United States has deployed it in various conflict zones, such as Iraq and Afghanistan, using large cargo planes, such as the C-5 Galaxy. The components are disassembled, packed, and loaded onto the aircraft using the cargo ramps. Upon landing, trained specialists set up the CRAM system, which is then moved to a specified location to counter enemy projectile strikes. The CRAM has an enclosed control station known as Forward Area Air Defense Command and Control, which primes its M61 Gatling gun to fire when threats are instantaneously detected within the range. The CRAM incorporates an advanced search and track Ku-band radar system that provides autonomous target detection capabilities. On the other hand, a forward-looking infrared FLIR camera enables it to engage, prioritize, and kill those aerial threats in both daylight and nighttime environments. The CRAM protects the military bases in a war zone, which is why maintaining such technology requires much effort behind the scenes. The soldiers must repair generators instantly, maintain warning devices, and get the radars back online if they're down to keep the system up and running. Moreover, if the batteries connecting to the CRAM system are charged through solar panels, they must be maintained thoroughly. The CRAM's naval equivalent, CIWS, was initially developed as an automated weapons defense system in 1973, incorporating a 20mm Vulcan Gatling gun. It was not until 2004 when the Navy appraised Phalanx CIWS as a possible ground-based variant due to its capacity to interface with a multitude of sensors to provide cover to ground-based forces. Although CRAM and CIWS are pretty similar, one major difference between them is the choice of ammunition. Phalanx CIWS fire tungsten, armor-piercing rounds, whereas the CRAM uses 20mm high-explosive incendiary tracer, self-destructing ammunition. Apart from CRAM, the U.S. Armed Forces use several other air defense systems to provide cover to ground crews, such as the renowned MIM-104 Patriot Missile Defense System. The Patriot system can be set up in less than an hour because all components are truck or trailer mounted. Upon reaching the designated area, the crew sets up the feet of the M901 launching station which stabilizes and distributes the launcher's weight. Simultaneously, the crew prepares the ANMPQ 5365/65A radar set, the OE349 antenna mast group, and the EPP-3 electric power plant to make sure the Patriot missile system is ready to fire in no time. When the radar detects the presence of an incoming threat, the system either initiates the launching system automatically or the interceptors are manually fired from the Launcher Electronics Module, LEM. During the missile's flight, the Patriot system continues tracking the target using its radar and can make mid-course guidance updates to adjust its trajectory. The missile canister stores the Patriot's interceptors, and each canister can carry 4 PAC-3 missiles, which sums up to a total of 16 rounds on each launcher. The Patriot missile is mid or long range. Therefore, the U.S. has several other short-range defense systems to protect ground units against aerial threats. One such example is the Avenger Defense System, designated as AN/TWQ-1, which is an American self-propelled surface-to-air missile system. It has a gyro-stabilized Avenger turret with Stinger missiles mounted on a 4x4 Humvee, high-mobility, multi-purpose wheeled vehicle, operated by a crew of 2, a gunner and driver. The Avenger Defense System is efficient in acquiring, identifying, tracking, and engaging low-flying helicopters, aircraft, and UAVs. Like Patriot missile defense systems, Terminal High Altitude Area Defense, THAAD, intercepts missiles during their terminal phase of flight. THAAD can detect and track enemy missiles at ranges of 870 meters to 3,000 kilometers, meaning they can obliterate short, medium, and intermediate range ballistic missiles either inside or just outside the atmosphere. It takes around 30 minutes to load a THAAD launcher with 8 interceptors, which are housed in 6.6 meters long, 1,044 kilograms launch canisters. These interceptors carry no warhead and rely entirely on their kinetic energy of impact to destroy the incoming missile. In modern-day warfare, drones have become a major threat due to their ability to carry weapons. The U.S. Armed Forces use Medium Extended Air Defense System, MEADS, to detect these aerial targets and shoot them down. On the 29th of November 2012, MEADS intercepted its first target at White Sand Missile Range. From Sweden's Archer artillery to the U.S. C-RAM, Patriot, and THAAD systems, these defenses showcase a global commitment to innovation and security. They illustrate how nations are not just safeguarding borders, but actively shaping the future of modern warfare. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.